Let's see how we can use the calculator to start answering some of our questions from chapter 12. So what we're looking at here for chapter 12 is this question about data being gathered on the number of hours a student works on homework each week and their GPA. So remember, with scatter plots, we're looking at pairs of data. So we have the pair of someone has 12 hours that they work on homework each week, and then their GPA is 2.97, and then 8 hours, and they have a GPA of 2.78, and so on and so forth. So let's take a look at the calculator. So once you turn it on, you're going to go over to Stat, and then you're going to go to Edit. And then you're going to enter in your data into these L1 and L2. So L1 we'll put in our hours, and then L2 we're going to put in our GPA. So really what we're saying when we're thinking about this is that our X is going to correspond to hours, and then the Y is going to correspond to GPA. So we're thinking about the hours will be X, or Y will be GPA. So really, if we're also thinking about this maybe in terms of science context, we could think about this being an independent variable. And then our Y, we're really thinking that this is a dependent variable, which in this case, it makes sense. Probably the hours is the independent variable and the GPA is the dependent variable. That makes sense in this context. Okay, so let's take a look at how we can start to graph this and see these. So if you go and you press the second button and then you press the Y equals, because above it says stat plot. So you press the second Y equals, you go to stat plot. Right now our plot is turned off. So I'm going to press enter, and then I'm going to turn this on. Now below you have a type of what you want. We want this first one to be selected. It's going to be a bunch of dots. Our X list is indeed our L1. That's what we said. Our X variable, our X is the hours, and the Y list is the GPA, which is our second one. And then the marks, you can choose whatever you want. I like this first option here. It's the most visible. Now if we go and press graph, you see there's some dots plotted, but maybe not all of them. So how we can make sure that we see all of those is we're going to go to zoom. So press the zoom button in the middle top, and you're going to go down until you get to zoom stat. So zoom stat will be your option, and now you see how the data has been graphed for you. So that's what it looks like on your graphing calculator. And then over here, if you were to sketch it by hand, say on a quiz or on an exam, you will make sure that you label your axes. So you would put hours, say on homework on the x-axis, and then you would put GPA on the y-axis. And so you could mark things where, let's say we go up by 5s, for instance, 5, 10, and 15, 20, oops, didn't draw this long enough, 25, and then our GPA, let's say we have a 1, 2, 3, 4. Then we just go ahead and we can draw these by ourselves. So we would have a 2 would correspond to a GPA around here. We would have 8 hours would correspond to a GPA of 2.78. And so on and so forth. So you get the gist of what we want this to look like. Okay. So, but back to the calculator. So we get to see this, and this is going to be really nice because it allows us to visualize, do we have a strong linear relationship? Is it a weak linear relationship? Is this positive or is this negative, or is there no relationship? So based off all of the things that we see here, what you should indicate is that this is a strong positive relationship. And I guess we can be particular, this is a linear relationship. It seems to be fairly close to this line. So this line over here, it seems to be pretty close to that. Okay, so if we go back to the calculator, let's figure out what is the equation of this line of regression, or this best fit line. So we can press stat, we can go over to calculate, and down here, so you have some options. There's going to be a lot of different ways to calculate this, by the way, but this right now, we can go down to this ln reg ax plus b, Or you could go down and your calculator might have linreg a plus bx. Doesn't matter which one you choose, just make sure you realize that one of them has a by itself and b is with the x, and then the other one has a times x plus b. So let's just choose this first one, press enter again, and you have popped out the linear line of regression. So y we said was ax plus b, but in particular in this situation, our a is 0.0728 times x plus our b is 1.957. So this is the line now that should fit our data fairly well. So if we go back over to y equals, we can enter this line into our calculator. So 0.0728 times x plus 1.957, and we can graph this. So this looks pretty good, right? This makes sense. This line is what we expect it to be. Now remember, we said x was ours and our y was our GPA. So if we wanted to do some approximations with this, we could do some estimations. So we could say, let's estimate the GPA for a student with, say, 10 hours per week of homework. So let's say they're working on homework 10 hours per week. We can estimate the GPA. And so what that means is our hours is going to be 10. So we just simply plug that in. So y would be 0.0728 multiplied by 10 plus 1.957. So then this just becomes 0.728 plus 1.957. And so if we round this and estimate this, this would end up being a 2.68. So this would be your approximate GPA. So that is how we can use this for estimates. Now remember, we said there's a difference between interpolation and extrapolation. So in this situation, you could ask, is this interpolation or is this extrapolation? This would be an instance now where this is interpolation. Because in our situation, we tried to approximate this value over here. We tried to say when x was equal to 10 and we had this line of best fit with our data, whatever this would look like, we're trying to estimate this point on the line. Now this fits within the range of the x values and y values, so this is good. We trust interpolation. That's what it would look like. But we could now see an example of when does this really stick out as something weird. So we could do now another example of, now let's approximate the GPA of a student who does, say, 60 hours of homework each week. So in this situation, our line, as you see on the graphing calculator, our line goes on forever and ever. There is no stopping point. So any x value, we are allowed to plug into this, and we're going to get some type of number. So let's see what happens when we try to plug this in. So we'd be having y is equal to 0.0728 times 60 plus 1.957, and so we get a GPA that is roughly 6.33. Now, obviously, this makes no sense. Right? If you do 60 hours of homework each week, I doubt you have a very good GPA because that's way too much time. But also, you obviously can't have a GPA that is 6.33. And so this is one of the problems of why we don't trust extrapolation. So interpolation, those are values that we can trust, approximating it with the line of best fit within our range. Extrapolation, we don't trust that. That's going to be outside the realm of this. And also, the other thing you can see on the other side is even if you set, say, x is equal to 0, right, in that situation, how could you spend no hours on homework and still have almost a 2 GPA? Or even, technically, there's no restriction that says I can't plug in x equals -1. Right, context, that makes no sense at all. It's not a reasonable x value. How could you spend -1 hours a week on homework? But again, that's where extrapolation becomes an issue. But remember, this is why we care about the regression line, our line of best fit, is because we can use it to make approximations, because this approximation that we had for the GPA being 2.68, that's a pretty decent approximation. So we'll do another one based off of hypothesis testing and in a different video.